All right, welcome to the first August community call. My name is Mark Fussell. I am your host today. I am a maintainer on the Dapr repo. It's wonderful to be with you here today. We have a very unique lineup today. We're going to start off with Shivam, who's going to dive into a binding that's going to be introduced inside V112, the next release of Dapr, which is the Azure OpenAPI binding. And he's going to give some great demos about how that gets worked. As I say, there's going to be a V112 release. We're then going to dive into Mauricio, talking about work he's been doing on the OpenAPI spec for Dapr. Then Yaron will also talk about an upcoming feature in the V112 release on the Outbox pattern, which I think is an incredible addition that we're going to see about how it's going to really tie together some unique capabilities and really empower you to achieve some scenarios that have been pretty difficult up until now. I will do a little bit of show and tell, and then we'll have time for some open discussion. So with that, I am going to hand over to you, Shivam, and you take it away. I'm going to stop sharing, and I'm going to let you share your screen.
Yes, I'll be sharing my screen. Thank you. Let me know as soon as it is visible.
We can see it.
Perfect. So before diving into what actually is the output binding for Azure OpenAI and what are the features that it's going to add, let's first look at how it all started. So soon after OpenAI had released its GPT 3.5 model, and when the hype for ChatGPT had started, someone filed a proposal that using Azure's OpenAI as an output binding is an exciting prospect, and he was right. It is. So since then, we have started the work to add the Azure OpenAI output binding, and it has already been added. So it's right now in alpha stage, and it has been added for the next release of Dapr, like Mark said, which is V1.12. So we already know what output bindings are. So I won't be going deeper into that. What this change is going to bring, it's simply going to bring a new output binding for Azure OpenAI. And what are the operations that it's going to support? First, it's going to support the completion operation. I'm going to go a little deeper about what these different operations are. It's also going to support the chat completion operation, and finally the get embedding operation. So the completion operation, as it sounds intuitively, it simply completes the message which the user is sharing. For example, in the image over here, you can see a dog is. So the operation will simply complete it. A dog is a domesticated mammal, as simple as that. Then we also have the chat completion operation, where in this operation, not completed, but it is actually responded in a human form. For example, you can see here that the user says, "Hi, my name is Shivam," and the response is, "Hello, Shivam, how can I assist you today?" This image is slightly deceiving because in the second user response, you can see that the question is, "What's my name?" And the operation is actually able to respond that your name is Shivam. But we can do this with the help of chat completion operation also, that I'm going to show in the demo soon. But it's important to understand that history of the previous conversation is not stored by default, but there are ways to do it, which I'm going to show. And finally, we have the get embeddings operation. So embeddings simply mean the vector representation of data. So for example, here I have a string, the capital of India is Delhi. So this operation simply returns an array of floats, and the length of this array is 1526. All of the behavior, all of the return type is same as what you will get from the official Azure OpenAI APIs. So that is it. I'm going to show small demos about each of the operation. I'm also going to show how you can configure this output binding and some more ways to use it more effectively. So over here, I hope the font is big enough. If not, please let me know. So to get started with the OpenAI binding, you need to simply create a component of type bindings.azure.openai. And what are the properties that you have to share in the metadata? I'll show it with the official documentation itself. So one is the endpoint of the Azure OpenAI, and then you have the API key. Now the API key is actually optional. So we also are supporting Azure Active Directory authentication. So if you don't share the API key, then you can actually give your Azure tenant ID, client ID, and the client secret, and you will be good to go. For example, over here, I am using the API key for authentication, but other than that, I could have used Azure Active Directory as well. Now, what I am going to do is, I'm going to run, so I have a small app which only has one API endpoint. So I'm just going to run this. I'm going to go into a little more detail on what this API does in a minute. But first, let's keep this running. So I'm simply going to run this app, import. So let me go back to Postman. Perfect. So the Dapr component is running on HTTP port 53647. So I'm going to call this output binding just in the way we call any other output binding, and the name of the binding is OpenAI. And I'm going to do the operation. I'm going to do the completion operation, and all the other parameters. So all these operations accept a lot of parameters. One of them being the deployment ID. So you can deploy a lot of models in your Azure OpenAI instance. So you need to mention the name of the deployment ID, the prompt, the message which you want the OpenAI to complete for the completion operation. And then some other parameters. I'll refer to the documentation for this. So some of the other parameters like max token, which means what is the number of tokens you want to use, and so on. I won't go into details because it's an OpenAI concept, so I won't repeat it. So you have some of those other different parameters. So let's run this API. Let's see what response we get. So we are calling the completion operation. So I'll just enlarge this a bit. Right. And one more important thing, n equal to 2. So n simply denotes how many responses you want from OpenAI. So for us, n equal to 2, which means we want 2 responses. So one response is this. So the prompt was a dog is, and the response is a dog is a great pet. It's important to note that it got the response is incomplete because of the max token. So more max tokens you give, larger response you get, and so on. And a dog is a great pet, and a dog is man's best friend, and so on. You also get some other responses, like whether the message sent by the user has hate speech in it, has self-harm symbols in it or not. So all of that is also returned to you. So this was the completion operation. Now let's look at the chat completion, which simply means give me a response like I would have got from a human. So when you are adding the messages for chat completion, you need to specify the role of the message. Now roles can be of 3 types. It can be either system, user, or assistant. So for example, here I have the system message that you are a bot that gives really short replies. It means how you want the responses to behave. And then you have the user message, which means the message that you want to pass. So here it is, just that I want to listen to a joke. And again, like I said, n equal to 2, which means I want 2 responses. So I'm going to send this as well, sending request. There we go. So again, the same multiple parameters, whether the message asked by the user has any symbols of hate or self-harm or anything that could be injurious. And then we have the response from the assistant. So as you can see, the role is assistant, which means the API has replied to it. And you have jokes, why don't scientists trust atoms? Then if you scroll down, you will have all the responses, the array of the responses, which is what happens to short-handed equations, and so on. So this was the chat completion operation. And then we have the embeddings API. So again, you mentioned the deployment ID. It's important to note that the deployment ID for all the operations are not the same. For example, embeddings is only supported by the ADA model. So the deployment ID of the ADA model that you have deployed in your Azure OpenAI instance, and the message of which embedding you want. So for example, I have the message, the capital of France is Paris. I will send, and as you can see, I have an array of floats. So then you can go ahead and use this array in multiple ways. For example, in RAG pattern to search from a database, use feeding your own data and so on. I won't go into much detail into that. So then you have this. In the documentation, we do have mentioned all the data parameters. We do have examples on how you can run the APIs along with responses. So you can refer to that. Now, one other thing that I wanted to touch before completing the demo is, for example, in the chat completion, if you say, like I showed in the slide, you say, hi, my name is Shivam, it responds to you, the operation is completed. But then if you ask, what's my name? Like, just ignore the image for a moment. It's not going to know because the data that you passed it before is gone. So what we need to do for that is we need to store the history of the chat conversations. For example, over here, if I just add another property, for example, no, let me just first do this. What's my name? So the user is asking, what's my name? So if I do a send, then it's going to reply, I don't know, you tell me. And again, it isn't knowable because I've not given the information to it. So one way to fix that would be if you give the context before. So my name is Shivam. Again, by the user, the role is still user. Now if I do a send, okay, then you can see in the second response, it says your name is Shivam. So it's able to fetch from the context. Don't know why it says this. Let me send the API again. Okay, so one of the responses is right and the other one is random. So you can also check the randomness of the response using some of the parameters like temperature. So the API function that I made over here, what it simply does is, for example here, I've simply made a bot which uses the Dapr output binding. For example, I say, hi. So my app is running on the port 50051 and the endpoint is chat completion. So if I say, hi, the response I get is, hello, how can I assist you today? Now, if I share, what is my name? Now let's first send the name. My name is Shivam. So if I share that and I get responses, hi Shivam. All right. Now after this, I could actually ask what is my name. Why? Because in the API, what I've done is I have an array which is called the message array, which is simply appending all the messages which the user is giving. So as soon as I get a message, I append it in the array and I add the role of user. And then I send the entire context to the Dapr output binding invocation. So this is a way how you can store the history of the chat. So now if I ask, what is my name? It will actually be able to reply to me that your name is Shivam. So this is how you can uh, use the output binding in multiple ways. If you want to store the context, if you want to store the history, then you can do that as well. So that was a demo of the different operations that it supports. The documentation is already complete for the alpha stage, and it is hosted in the link that I have mentioned in the slide. And like I mentioned, it has all the details about the different parameters, responses, and so on, along with reference to some of the related articles. So that should be all about the Azure OpenAI output binding for Dapr. I'm open to questions if anyone wants to go ahead.
That's excellent, Shivam. Yeah, if anyone have any questions, kind of either open up your mic and ask them or just post them in the chat window. It's good to see that we've actually brought AI now to Dapr in the first sense.
I'll be stopping the screen share and I'll be looking at questions.
Yeah, I just want to say thank you for contributing this component. It's really great. I also like the API surface you've created for it. It's really useful. Just one note, the world is a bad place, so you might want to rotate the API token. That's now recorded in history.
Yeah, sure. Yeah, I'm going to do that.
All right, but if there aren't any questions, post them in the chat window. We can always answer them there. Thank you. Great demo. Great to see that. And thank you for, as Yaron said, thank you for the contribution. It's great to see these added components, especially from the community. So thank you. So with that, we'll move on to our next session and we'll move on to Mauricio to talk about OpenAPI spec. So Mauricio.
Great. Yeah, let me share my screen as well. I don't want to take too much time in this call, but I wanted to share kind of like some progress that I've been doing on the OpenAPI spec definition for the HTTP endpoints for Dapr components. So basically, I've created a pull request maybe 3 weeks ago into this repository called SIG API. And that repository now, it contains kind of like the first iteration of the OpenAPI schemas for the state store and for the PubSub component. Inside this repository, let me show you, I've defined some GitHub actions that basically are testing these API schemas, right? Like if you go to state store API, you will see that there is a state store YAML file here, which basically is the OpenAPI schema for some of the endpoints that are related with state, basically. And I wanted to show here the automation that it's basically testing this against Dapr. And this is using Docker Compose in order to start an instance of Dapr inside GitHub to actually test that the schema is actually working against the implementation. And I have that for state store and PubSub. And here you can see that I'm using a couple of tools in order to test this automatically. So I'm using a tool that's called Portman, another tool that's called Newman and Postman as well, just to execute automated tests against these APIs. So every time that we commit something into the spec, in this case, we will be using Docker Compose to run, these new endpoints or these new changes against, a real instance of Dapr running. So I finished this, and this is already merged there in main, but I wanted to take this one step further. And for that, basically, what I'm showing here is that I just created a pull request to Dapr with some integration tests with the generated clients from these OpenAPI schemas, right? So now I'm taking the schemas, I'm generating clients using like Go clients in this case. I can do the same for other languages, but I've started with Go. And then I'm running integration tests with something that Josh contributed some time ago, which is basically some integration tests that do not use Docker, but start the Dapr binaries kind of like right there and pretty fast. So if you take a look at that, now what are we doing is we are testing here on one side the spec itself against the Docker, the Docker version of our Dapr. And then we are running integration tests. I'm just trying to find my tabs here. I'm running integration tests against the generated clients, right? So this is kind of like the pull request. And what I wanted to show here is that I am creating, the clients, the client code on this side using, OpenAPI code gen. So this is just code generation based on the definitions of the OpenAPI. And then what we are doing here is we are running this very simple test for now, which are basically consuming the client, right? In this case, I'm testing PubSub, which is defining kind of like what the PubSub component looks like, and then running that locally, consuming the client, in this case, the PubSub client, which is basically submitting and publishing some messages with somebody, right? In this case, what we can test now is that not only the API is correct and works against Docker Compose by running these Postman collections with tests, but also that if we generate the client and run our integration test in the same way that all the integrations tests are being running, the clients are working as expected. I wanted to show this in this call because I wanted to share this with the community. And if somebody is interested in helping with this initiative, please get in touch because I will be actively trying to make the specification as complete as possible. So we can actually look at our APIs, point people to these APIs, and start sharing this API with other teams and other projects. I think that that's pretty much what I wanted to show. Also, I will appreciate some reviews on this pull request and suggestions. If you know that I should be testing these clients in different ways, please let me know. And that's pretty much what I have to share today.
Yeah, that's pretty cool. I think the emphasis here is the fact that we're making sure that there's an API specification for the Dapr APIs that you can actually go and look at based around
Exactly.
And there's an official way of seeing this.
Exactly. And now you can just actually browse those schemas and generate clients from here, like any language, any tech stack that you want to use. Cool. Thank you.
Excellent. Has anyone got any questions on that?
Any questions?
As Oli mentioned in the chat, people are asking about OpenAPI specifications. And this is something that we've been looking to add for a pretty long while now, because it not only helps in the testability and the discoverability of the different Dapr APIs and endpoints, but it also helps position the APIs as something that can be decoupled from the implementation and be implemented by other distributions, right? We've always been talking about maybe IoT edge distributions of Dapr coming along, something like, maybe a Rust implementation of Dapr that's really lightweight and that implements a part of the API for like edge-based deployments. And this really helps these third-party implementations to implement some of the Dapr APIs, not all of them necessarily, but also all of them if they want to. So this is really great to see.
Good stuff.
Okay, excellent. All right, thank you, Mauricio. That's great to see that work. And yeah, we'll continue to promote it, and hopefully other people join in and help with the other APIs. You've started 2, and we're going to get the remainder covered.
Perfect. Yeah.
Okay, all right. Thank you. So with that, then, Yaron, let's move on to you and cover our final session.
Yeah, okay, I'm going to share my screen. And let me know you can see it.
Yep, you can see it.
Okay, so today we're going to cover a feature that's been highly requested by the Dapr community for a pretty long while now, and that's the Outbox pattern. I'm really happy to say that this is coming as a preview feature in Dapr 1.12. And let's talk a little bit about what the Outbox pattern is. So essentially, the requirements for an Outbox pattern in your code is that when you save a message to a database, you also get the guarantee that at some point in time, that state that you've saved into the database will be published to a pub sub broker. So this is like a business domain notification thing. You saved state, and then you need to send a business event to one or more subscribers to basically notify them that the state has been saved. So ensuring that the topic is published to once a database message has been saved is one requirement. And then the other, which is really, really important, is that a topic cannot be published without the message first being saved to the database. So if you basically don't want to alert the subscribers if the state is not in the database. So you kind of like need a transactional type of operation across the database and the message broker. And this is essentially how it works today, not in Dapr. This is generally how someone wanting to implement the Outbox pattern would do it. This is a very, very general architecture, and it's extremely hard to achieve, and we'll discuss why. So on the left here, you have the service or entity. This is the application. This is just a diagram I got off of Google. And what you would normally do is you'd write a transaction into a database, and you would have a dual write. So on the left here, this is the update state. This can be your business state. This can be like an order or whatever your application is doing, and this goes into the state table. The state table is queryable by end user or other instances or applications. But then the other write is essentially a record, usually a duplicate record of that same item into the Outbox table. Now, why do we have this extra write here? This is because to guarantee that this message or this saved state is going to be published to a pub sub in the future, there is usually a third-party process. It can sit in the same process or a different process. It's essentially decoupled, and what it does is it'll go to the database, it'll scan the Outbox table, it'll get all of the messages that need to be sent, and then it'll start sending them to the queue. It says queue in this case, but it doesn't have to be a queue, it can be a queue, or it can be a pub sub. And then you have the subscribers that are really decoupled. So this is something that's extremely tricky to do yourself. And that's because there's lots of places where this can go wrong. First of all, when you're saving double messages into the database, depending on the cloud service that you're using, you might exceed limits. You're writing the same state twice. If the Outbox table write fails for whatever reason, then the state table item will be rejected also, which means that transactional saves are much more error prone. And then you need to write a process that scans the table. And this really works well with SQL databases, or I won't say it works well, but it works easier with SQL databases, where you can scan a range of items and then have some business logic that marks those that haven't been processed and process them. But if you're using a key value store, for example, like many are using today in mostly microservices and cloud native architectures, this becomes really difficult because not all of them have scan or list operations. And even if they do, it's usually a blocking operation on the database that hurts performance and might even block other callers for completely different states. And then this all gets even more difficult if you're running in a distributed environment, because if you have multiples of these Outbox relay processes that scan the database, then you need coordination through a database, and that is even more tricky to get right, because you need to start doing things like ownership leases and marking who gets what and partitioning them, and this becomes a real pain. So unless you live in paradise, which in this case means your system only has one instance, this is going to be a problem at scale. And that scale has even one more attribute to it. It doesn't necessarily mean that your system technically runs at scale, but if you have many programming languages in your organization, if you're using C# and Python or JavaScript and any other language, then you're basically gonna need to rewrite this logic for every programming language, and it's hard enough to get right. So yeah, it's very tricky, and there are open source libraries out there today that do this. But most of them, well, all of them actually, are language specific, and they stop short at supporting maybe one or two databases. Usually it's MySQL and or Postgres, and usually the queue mechanism is Kafka. So if you happen to be using a single programming language in MySQL or Postgres and Kafka, then you're good. But there's like dozens of databases and pub subs out there. Okay, so moving on, we've enabled this in Dapr. This is coming in 1.12, and this is essentially the entire user experience for how to use this. So we have the transactional state API in Dapr. That's an API that exists today. It remains unchanged, and all you need to do is just post a body, a JSON body for this transactional state operation. And I think I might have skipped something here. No, I didn't. Okay, yeah, so you will be posting a message body to the transaction, and this API call is basically what Dapr has today. It remains unchanged, as I said. And on the Dapr component, if you haven't seen this before, this is a YAML definition of how you would, for example, configure Dapr to save this transaction to a Redis database. So on the metadata part here, we have name and password. This is just the connection credentials to Redis, but on here, we've added two new ones, two new field options called Outbox Pub Sub and Outbox Topic. Outbox Topic here is new order, and this basically means every time you write a state transaction to this state database, you're going to publish a message to the new order topic. And Outbox Pub Sub is basically allowing you to choose which pub sub Dapr uses to store the Outbox state items. And this is related to the implementation, which we'll cover in just a sec. And the really, really nice thing about this is, first of all, this is consistent. You can use this Outbox pattern from literally any programming language. And you can use any Dapr transactional state store. So, you can even use key value stores for this, including, of course, SQL stores. So I think we have 13 or 14 transactional state stores in Dapr today. All of them support the Outbox pattern. And with that, you're not bound to Kafka. You can literally use any pub sub. But there is a preference for brokers that support competing consumers, just because, if you have more than one instance of your application, you might get messages being processed twice, which might be fine for you because that's in line with the at least once guarantees anyway. That's also in line with the original Outbox pattern. But if you choose a competing consumer message broker, then you remove those chances. And you're also getting order delivery, for the happy path. Meaning if you don't have multiple instances retrying the same, then most of the time you'll get order delivery. So there is a preference for that, but really you can use any pub sub and any of the Dapr transactional state source. So this gives you a really nice metrics of really any combination of a state store and pub sub that you can think of, whether it's queue-based or stream-based for pub sub, and whether the database is as a key value store or a SQL database. So how do we actually do this in Dapr? How do we achieve this magic? This is the internal architecture. I'm not going to go over a deep dive of that. Maybe we can do that in the blog post. But you have the application here, and it calls Dapr to save the state. And as soon as Dapr receives the call, it won't actually save a state transaction to the database. It will publish a message which is not the business event that the user is expecting. Dapr will publish to the pub sub an internal topic that's basically telling any Dapr instance, it might be the same Dapr instance that received the call from the app or any other running Dapr instance in the cluster, that it should be on the lookout for a state transaction from the database, okay? So Dapr will publish this. If this fails, Dapr will return a retriable error to the application. The application will know that the transaction Outbox pattern has not been achieved and it can retry it. If the internal publish is successful, Dapr will write a transaction to the database, which is more efficient than what you'd normally find in the regular Outbox pattern, because here we're not saving the state twice. The state is saved to the user state table, and this is kind of indicative of a key value store. As I said, we can also use MySQL databases. This is just an example of the key value, just to make things simpler for explanation. So we have a key of 1 and the value is hello. This is the business state data that's being saved. So Dapr will save this as a single transaction, then we'll save a second transaction, which is an identifier. I'm not going to go into why this is GUID-X, but Dapr is basically going to save an identifier that identifies this state table. Okay, so at this point in time, if that is successful, then the application will know that it has achieved this asynchronous guarantee of a transaction between a database and a state. And a Dapr instance, whether it's the same one or a different one, will basically consume the publish that was the internal published message that was published. It'll get it. It'll get the state key here. It'll check if the state has been saved to the database. It'll retry. It'll use resiliency. If it's not successful, then it'll knack and be retried at a later time. This is why it's considered transactional. And Dapr is essentially using the pub sub to store the states that's evenly distributed between multiple consumers. So this really helps in not hammering the database, not doing any sort of lease ownerships or anything like that. We're using the pub sub to do all that for us. And once the consuming Dapr instance has taken the data, it will publish it to the end user topic, the one that we've in here called new order. And and then it'll just delete this really, really small key from the database. And again, we're not saving the value twice, which is nice. So where is the value coming from? When Dapr publishes the internal topic, it'll save the state that it has just written to the state table. This is also really nice because it means that, if at any point in time a delete operation deletes the state from the database, we are guaranteed to actually publish the state that was saved at the time where the app got an OK response back from Dapr, or saved the state to Dapr. So this is essentially an event-sourced kind of append-only record log, which is really nice because it means we don't have to worry about state mutations along the way. And for now, let's just see how this works. So I'm going to be using a master branch version of Dapr, which is the latest state that we have. Might not be all that stable, but we will try to show a demo. So I'm going to go over to VS Code here. This is a simple Node.js application. This is going to be my subscriber. So in the diagram you saw earlier, this is going to be a notified JavaScript application that's being notified every time a state is being written into the database. If you haven't seen this before, this is how I subscribe to topics. So I'm telling Dapr on startup, hey, I want you to subscribe to the topic Yaron for the pub sub. This can be whatever name we give it. And I want you to notify me when events come on the endpoint that I'm opening up, which has your own URL. And this is here. So every time a state transaction is saved, Dapr is expected to notify us on this your own endpoint. What I'm doing here is pretty simple. I'm just logging the response and setting the status. So it's all pretty simple. If you know Dapr, this has nothing new, nothing related to Outbox here. You can use existing subscribers without changing a single piece of code for the Outbox pattern. So that's kind of nice. In here, I have the pub sub. I really don't have anything special on the pub sub. There's 0 changes you need to make to the pub sub components. This is just using Redis as a pub sub that I'm running locally on my machine. And this is the state store YAML. So this is very similar to what you've just seen on the slides. I have an Outbox publish pub sub. This is pub sub. So in here, I'm going to explain what this does now. I'm using the same pub sub that I'm going to use to deliver the business topics as the pub sub that Dapr uses to basically coordinate the work of the Outbox. So we're giving users the flexibility to choose the same pub sub for everything, meaning the same pub sub to send the business events to, and the same pub sub where Dapr uses it as an implementation detail to basically coordinate the work of distributing the internal messages. But if you want to, you can use 2 different pub subs altogether. You know, if you want to, for example, separate the Outbox infrastructure from your domain event infrastructure, then this can give you the option to do that. And this is the end user topic that we're going to publish to. This is Yaron, the same topic I've subscribed to in my application here. So what I'm going to do right now is use Dapr Run. Dapr Run is a CLI tool that allows me very easily to run a Dapr sidecar locally. And then it's also going to launch a JavaScript application with Node here. So there's nothing special here. I'm just giving the sidecar a name. I'm telling it where to look for the YAML definitions for my state store and pub sub, some core definitions, non-important, and the Node application that I'm just going to use as a helper utility to just run my application after Dapr has been running. So I've just run Dapr, so I have the sidecar up and running here. And now I'm going to go over into Postman, just going to zoom in a little. And I can call the state transaction API. This is the same API as you've seen earlier, remains unchanged. This is how you would write a state transaction to Dapr. Again, this is completely unchanged. Nothing for Outbox is required here. And I'm basically saving, one operation in this case, which is an upsert. And this is my key of 1, value of ABC. Kind of boring. I wasn't in the mood today for anything more interesting than that. So this will have to do. And yeah, now we can just start sending it. And we can see that this took 11 milliseconds. We got a 204, no content back, which means Dapr has processed the operation. And if I go to my subscriber, we can see that we've saved the state, but we've also got the notification for the business event. So this has been a single transaction essentially over state and pub sub. And if I go back to Postman here and I get this key here, I can see that the state has been saved. So yeah, this is the Outbox pair in Dapr. It would be really great to get users' feedback to try it out. It's a preview feature, meaning we can break things like the specification. We might change field names on the components. We might rename them. We might move them. We might change the internal implementation. We might do a whole bunch of things. So this is a preview feature, and feedback early on is really important. Okay, so I'm going to stop sharing for now, and back to you, Mark.
This is pretty exciting and an amazing piece of functionality. So if that save fails to the database, you don't get sent the message, presumably, yes?
Correct, yes.
And so say the operation fails because there was a duplicate entry. You went that one reason or whatever reason that takes the transaction, yes?
Yeah.
Well, let's open it up for questions. Ollie's just posted, given 2 clients set the same key at the same time with different values, the e-tags are not used. Well, I'll let you read this. If the e-tags are not used, the last write will win. For the subsequent 2 messages that are published to the Outbox queue, Is there any way to differentiate which state operation was first and which was second?
Yeah, that's a good question. So yeah, we could add a sequence ID, but something you can do right now maybe is look at the timestamp, because Dapr will timestamp the time where the message was published into the pub sub. So you can use that. But again, if you have a distributed system, it's just like deciding which was the first message that was published. If you're just using pub sub, yeah, you can definitely look at that.
And did you also mention that this can be used beyond just key value stores?
Yeah, so the special thing about this is that it can actually be used with key value stores in addition to SQL databases. And you'll usually see the Outbox pattern used with SQL databases just because it makes the implementation easier to scan ranges and coordinate the work.
So in that regard, how would that make this sample different?
Sorry?
How would that make this example different? Would you
it wouldn't. It wouldn't. If whether you're using a MySQL or a NoSQL database, it doesn't matter. The state transaction API is all you care about as a user. That's part of the Dapr abstraction for state transactions anyway. We save transactions to SQL databases, to key value databases. You really don't care. Use a single API.
Excellent. So if people want to find out more, they can wait until the 1.12 release, and we'll see it then and try it out, and it'll be a preview feature then, yes?
Yes.
All right. Any other questions before I move on? No? Okay. All right. Well, with that, let me share my screen again. And hopefully you'll see this. I'll just do a little bit of show and tell for what's been happened in the last couple of weeks. What's happening inside the community. First, I just always like to highlight a few blog posts that have been happening. Mark Duquier posted a great blog post on diving in depth to Dapr workflow patterns using .NET. He goes into fan out pattern, sequential pattern, and other things inside that. Go and check that out more. We'll continue to kind of show how the power of workflow happens with Dapr. Then you have Xavier, who did a blog post around syncing events from Event Hub to Cosmos DB. Arka Pravana Rava had a building microservices with Dapr and .NET intro. If you're looking into more about how .NET and microservices work together. Anna did one that she talked about how to troubleshoot the Dapr certificate expiry, something that can happen quite frequently if you got to check your certificate expiry inside your deployed clusters. And finally, the Weekend Blogger did a topic on tuning Dapr-based messages for high throughput on Azure Kubernetes clusters. So feel free to check out these blog posts. If you missed this great recording, Kendall and Sam did a deep dive on service invocation. They covered some of the new topics that happened in 1.11 release, where service invocation can now call non-Dapr endpoints. And it's great to kind of hear how you use that feature. And they also sort of combined that a little bit with talking about both workflow. So they showed the power of both workflow and service invocation together. So feel free to check out this recording again. That's the YouTube link below there. Yaron has a talk coming up at WASMCon, which is happening in Bellevue. Am I right, Yaron?
Yes, Bellevue, Washington.
Bellevue, Washington. So if you are attending there in person in Bellevue, here in Washington, please come along and attend, and we'll be bringing together the two worlds of Dapr and WASM. And finally, kind of just a call out for that Dagrid sponsoring a survey on the state of Dapr. We'd love for everyone, community, to contribute towards this. We share all the results with the community. So please take this survey, because it will really give us kind of an insight to what's happening across the whole Dapr community. So please take the survey, and then we can share all the details with you. And here's the URL to go and take that. And finally, of course, I always want to do a shout out for our Dapr Discord. If you have other questions that you want to answer, or you want other topics to dive into, go to our show and tell and post them there. We're always looking for things that we want to pull out onto the Dapr community calls. And of course, it's a great place to go and ask questions. So with that, we're at time, but of course, we always have a chance to ask a few questions. If people have any questions on the topics we covered today, or anything else that we'd just like to draw out about the release, or any other topic you'd like to cover. So either open up your mic or just post something in the chat window. All right. Well, if you don't have any topics, I think we'll call it for today. Thank you for attending this session. And this will post on our YouTube channel, and have a wonderful day.
Thank you.
Thank you,
Thank you.
folks.
Right.
Thanks,
Thank you.
everybody.
Thank you. Bye-bye.